Hello, this is lesson 9.2 and 9.3, prime factorization and order of operations. So let's get started. Okay, so prime factorization and order of operations. Standards are I can find factors of numbers of a number or numbers. And we've done this in the beginning of the year, so this should be review for you. And I can find the prime factorization of a number. We also did a little bit of this at the beginning of the year as well. And finally, I can simplify numerical expressions. The actual standard says EE1, write and evaluate numerical expressions involving whole number exponents. I'll minimize myself and let's get going. Okay, just to remember a review of the definition of a factor. A factor is a number that divides into another number exactly and without leaving a remainder. So 2 divided by 64. When 2 is divided into 64, there is no remainder. Therefore, both 2 and 32 are factors of 64. The answer to this problem would be 32. So that's where that comes from. So 2 and 32 are factors of 64. Let's find all the factors of a number. So you have 18. So what you do is you take 1 times 18. You always take the 1 times the number first. And I like to put them like that so that we can put them in order. The next one would be 2 times 9. And then what? 3 times 6. And notice how they're nicely and neatly in order, 1, 2, 3, 6, 9, and 18. Let's do the same with 30. 1 times 30, 2 times 15, 3 times 10. What else? 5 times 6. So that's a nice, neat way to do that so you don't miss any factors in between. Okay, it's your turn to try finding the factors of a number. Okay, welcome back. Let's continue. Let's find all the prime factors of a number. And I always find this to be fun. We did a little of this when we were finding greatest common factor earlier in the year. Prime numbers are whole numbers greater than 1 that have only 2 factors, the number 1 and the number itself. So for example, 29 has 2 factors only, 1 times 29. There are no other numbers that multiply together to give you 29. How about 13? That's also prime, 1 times 13. How about the number 2? The only thing that multiplies together to give you 2 is 1 times 2. How about 3? The only number that multiplies together to give you 3 is 1 times 3. What about 5? The only numbers that multiply together to give you 5 are 1 times 5. Another prime number would be 7. And then not until 11. And then we go back up to 13, etc. So there's a lot of prime numbers. You just have to think through which ones are they. The ones you're going to mainly work with are probably these that I gave you right here. Okay, so let's see how to use prime factors to make the prime factorization of a number. Any number can be broken down into its prime factors, its prime numbers, using the prime factorization method, which uses factor trees. So you saw this earlier, probably forgot, it's been a few months. 18, we're going to pick 2 factors that multiply together to give us 18. Any 2 factors will work. I picked 2 times 9. You could easily pick 3 times 6, and that will also work, and it'll give you the answer in the end. So now when I multiply 2 times 9, I'm going to circle the 2 because that's a prime number. I can't split that any further other than 2 times 1, right? So it's going to stay circled. I still got to split 9. What can I multiply together to give me 9? 3 times 3. And notice how 3 and 3 are both prime factors. So I'm going to circle them. So there I have all the prime factors of 18. The prime factorization of 18 is 2, oh, that black bar at the bottom, 2 times 3 times 3. And then if I want, and you should do this, on the very bottom there, it says 2 times 3 squared, right? I put a little exponent with the 3. Why did I do that? Because 3 times 3 is really 3 squared. So you can write your prime factorization using exponents. Let's see another one. Let's try 30. What two numbers multiply together to give me 30? Well, you can pick any two numbers like 5 times 6 or 3 times 10. So I picked 3 times 10. Notice how 3 is already prime, so I'm going to circle it. But 10 is not prime. I have to split that further. So I'm going to do that with factors of 2 times 5. And notice that both 2 and 5 cannot be split any further. They are prime. So I'm going to circle both of them. So now I have the prime factorization of 30. The prime factorization of 30 is 2 times 3 times 5. And if I were to take 2 times 3 times 5 on a calculator in my head, I would get 30. And the back with the 18, if I was to take 2 times 3 squared, I would get 18. Okay. Let's do the prime factorization of 240. Okay, we have to pick two numbers that multiply together to give me 240, and there are a lot of choices. Remember, it doesn't matter what you start with, you'll end up with the same answer in the end. I'm going to do 24 times 10. 24 times 10. Now, both 24 and 10 are not prime, so I can split them up further. So let's start with the 24. I'm going to split that into 3 times 8. Could I have used 4 times 6 or 2 times 12? Sure, I can do that. In the end, I will end up with the same numbers for prime factors. So now 3 is prime, so I circle it, and I can split 8 up further. So 8 is going to be split into 2 times 4. Notice how 2 is now prime, so I circle it. I still have the 4 that I can split up further. 4 is really 2 times 2, and now I have 2 more primes, so I circle 2 and I circle 2. It's really important to circle the prime numbers as you're going along so you don't miss any. I'm not done yet because I have this 10 over here that I still have to split. So I'm going to say 10 is equal to 2 times 5, and 2 is prime, and 5 is prime. So now I get to list all the circled numbers as my prime factors. So 240 is equal to 2 times 2 times 2 times 2 times 3 times 5, all my circled numbers. Then I'm going to combine my 2 times 2 times 2 times 2 and write it as an exponent, 2 to the 4th power, and then times 3 times 1. So that's the way you should write it. Okay, you get to try some of these. I'll see you back in a moment. Okay, welcome back. Hopefully that went well. I'm sure it did. Let's continue. Now we're going to get into simplifying numerical expressions. Now pay attention to this. This is fun too, but it takes a little getting used to. A numerical expression is an expression involving numbers and operations. So operations are adding, subtracting, multiplying, or dividing, using exponents. So you always need to use the order of operations to simplify numerical expressions. If you don't use the right order of the operations, adding, subtracting, multiplying, dividing, etc., you'll get a different answer and your answer will be wrong. So let's see how this works. So we say please and my day at school. So that's our acronym, please end my day at school. The please stands for solve anything in parentheses first. The end stands for solve the exponents second. The my and the day stands for multiplying or dividing third. However, you do it whatever comes first from left to right. So as you read from left to right. So if you have dividing coming first on the left side, before multiplying, you're going to do the dividing first. That's why my and day, or multiplying and dividing, are on the same level. And finally, at school stands for adding and subtracting. Again, whatever comes first from left to right. So if subtracting comes on the left side first, you're going to do that before any adding. So let's see how this works with numbers. Okay, we're going to use the order of operations to simplify this expression on the right. 5 plus 18 divided by 3 squared equals. We have to use the right order. So we start with please. Anything, solve anything in parentheses first. Do you see any parentheses? No, neither do I. So none this time, so we go to the next step. End, that stands for solve exponent second. Do you see any exponents in there? I do. So you have to take this one step at a time, and you have to write the steps. You have to keep going below the previous step and writing it all over again. So 3 squared is my exponent. I'm going to do that first. That equals 9. Now I'm just going to bring down this 5 and this 18 and this dividing sign. Just going to bring it down onto the second level now. 5 plus 18 now divided by 9. All we did was the exponent. What's next? Please end my day. Multiplying or dividing, whatever comes first, from left to right. So if I am looking at this is 5 plus 18. I can't do that first. I'm on multiplying or dividing. So I'm going to keep going left, and I say, oh, 18 divided by 9. I'm going to do that first. Notice how you'd get a different answer if you did 5 plus 18 and then divided by 9. You have to do 18 divided by 9 first. So let's do 18 divided by 9. That should give us 2. And now I'm just going to, again, make another level and bring down the 5 and the plus and the equals. So now I'm finally to the last step, adding or subtracting. Whatever comes first from left to right. Well, all we have left is a 5 plus 2. The answer is 7. Now, if we would have done this out of order, we would have gotten a different answer. So we have to follow the steps, and we have to make each level, we have to rewrite the new step each time. So let's try another one. Okay, we're going to use the order of operations to simplify 21 plus 3 squared divided by 3. Please, parentheses first. I don't see any parentheses. So none this time. I'm going to go right to the next step. What's the next step? Exponents. Do anything with exponents next. So I see a 3 squared. So 3 times itself is 9, right? 3 times 3. And I'm just going to bring down the other numbers, the 21 plus and the divided by 3. I only did one step per row, one step per row. Now I'm going to do multiplying and dividing from left to right. Well, if I look, 9 divided by 3 is a division part, right? So 9 divided by 3 is 3. And then I'm just going to bring down my 21 plus. Notice how I only did one thing. Then finally, I'm going to do adding or subtracting. Whatever comes first from left to right. Well, we just happen to have only 2 numbers left. So 21 plus 3 is equal to 24. That's the answer to simplifying that expression. You may hear a loud noise. My family has my washer on right now, so it makes a little rumbling sound as it finishes doing the clothes, and it has about 9 minutes left, so you may hear that. Okay, let's continue. Let's try 6 times 2 to the third divided by 3 plus 1. Start with parentheses first. Do you see any parentheses? Nope. None this time, so go to the next step. Exponents. I see 1 there, so 2 to the third power. What is that? Well, 2 to the third power is 2 times 2 times 2. What does that equal? Well, 2 times 2 is 4. 4 times another 2 is 8. So that exponent 2 to the third should equal 8. And there it is. And then I just bring everything else down. 6 times, now it's 8, divided by 3 plus 1. Now I do multiplying or dividing, whatever comes first from left to right. Notice this time, I've got to go from left to right. I'm not going to do 8 divided by 3 first. I'm going to do 6 times 8 first, because multiplying is coming first in my left-hand side of the equation. Okay, so I'm going to do that first. 6 times 8 is 48. I'm going to bring everything else down. Divided by 3 plus 1. I'm not done with multiplying or dividing. So I'm going to do 48 divided by 3. That gives me 16. And then I'm going to bring down the plus 1. And then I can do my adding and subtracting. 16 plus 1 is 17. There's your answer. Okay, you get to try some of these. I'll see you back in a moment. Welcome back. Let's continue. We're going to use exponents with grouping symbols. We're still going to use our order of operations to simplify our numerical expressions. 4 times 9 divided by 3 squared. How do I do that? Well, I do please end my day at school. Please, I do the parentheses first. This time I have parentheses. So I do what's inside the parentheses first. 9 divided by 3. That gives me 3, and I still have this little squared symbol outside of the parentheses, so I got to keep that with my answer from the inside of the parentheses. So I have 9 divided by 3 is 3, and then I have to bring along the little 2. And then I just bring down my 4 times. Next, I do my exponents. Please end. So I see some exponents there. 3 squared is equal to 3 times 3, or 9. And then I'm going to bring down my 4 times 9. Next is multiply or divide, whatever comes first. Well, there's only multiplying left, so I do 4 times 9. That gives me 36. There is no adding or subtracting to do this time. I'm done. Okay, the next one, 5 cubed, or 5 to the third power, plus, in parentheses, 12 minus 2, and then squared. Do parentheses first. So 12 minus 2 is 10. And notice how I bring the little squared sign, the little 2, the exponent, with the answer to the inside of the parentheses. And then I just bring down the 5 to the third. And now I go to exponents. So I see an exponent. I see 2 exponents, don't I? So I see 5 to the third. That's 125. Why is that 125? Well, that's 5 times 5 times 5 again, right? And 5 times 5 is 25. And then I multiply it by the remaining 5 up here. And that gives me 5 times 5 is 5. Carry the 2. 2 times 5 is 10 plus 2 is 12. That gives me 125. So that's where that comes from. And then I have 10 squared as well. So I'm going to do 10 squared. 10 times itself is 10 times 10. 10 times 10 is 100. Now I do multiplying or dividing, whatever comes first. There's none, so I skip that step and go right on to the last step of adding or subtracting. It's adding. So I'm going to add 125 plus 100, and I'm going to get 225. Okay, let's see another one. 8 plus a fraction. 12 minus 8 squared divided by 2. I do parentheses first. So I'm going to do 12 minus 8 first. Notice how 12 minus 8 is 4. I keep the little squared sign with the 4. Everything else stays the same. There's still a 2 on the bottom, and then I'm going to bring down the 8 plus. Okay, exponents is next. So I'm going to do this 4 squared on the top. That's going to be 4 times 4, or 16. Notice how I kept the divided by 2 on the bottom, and I'm going to bring down the 8 plus. Okay, now I'm going to do multiplying or dividing. Whatever comes first. Well, 8 plus is adding. We're not on that step. I see that 16 divided by 2 is a division problem, so I'm going to do that. 16 divided by 2 is 8, and I'm going to bring down my other 8 plus. Now I'm on to adding and subtracting. Whatever comes first. Well, we're at the end where we only have to do 8 plus 8. The 8 plus 8 will be 16, and that is my answer. Okay, it's your turn to give this a try. I'll see you back in a moment. Okay, welcome back. Let's do some focusing on some higher order thinking. Explain why it is possible to draw more than 2 different rectangles with an area of 36 square units. But it is not possible to draw more than 2 different rectangles with an area of 15 square units. The sides of the rectangles are whole numbers. How do you find the area? What's the formula? The formula for the area of a rectangle is length times width. Okay, that's the area formula. So they're telling us the length times the width of one type of rectangle is 36. They're telling us the other rectangle's length times width is equal to 15. And the lengths and the widths have to be whole numbers. Can't be fractional parts. They can't be decimals. So let's see how that's going to look. Clear my drawings. Here's one rectangle that has 6 units going across. 1, 2, 3, 4, 5, 6. That's its width. And it has 1, 2, 3, 4, 5, 6 going up and down. That's its length. Or actually, we could say the width is this, and that's the length. So we multiply 6 times 6, and that'll give us 36 square units. This rectangle here, what is the length? Length is across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What's it up and down? 1, 2, 3. Length times the width, 3 times 12, is 36 square units. So that's another type of rectangle. That's a different rectangle from this one, but they're both 36 square units in size. Then we have this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. That one has 9 square units going across, and up and down it has 4. So 4 times 9 is 36 square units. There's more. You could do 6. We did 6 times 6. You could do 3 times 12. That's another one. I think 2 times 18 is another one you could do. So there's others. What you're doing basically is finding all the factors of 36 and making one factor the length and one factor the width. Okay, let's take a look at the 15 square unit rectangle. There's one that's got 15 length and 1 width. Altogether, it's 15 square units. Is there any other numbers I can multiply together to give me 15? No, just 15 and 1. Actually, there is. 3 times 5 is 15, isn't it? Yeah, so we could have done another one. So this one is not a correct problem. I'm going to pause it. I'm going to fix it and show you a different one in just a sec here. Okay, I fixed it. Instead of 15 square units, I put 13 because that one's prime. So this one's got 13 going across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And only 1 going up and down because 13 times 1 is 13 square units. And I don't know if I fixed the bottom, but let's see. So 36 has 5 different sets of factors that multiply together to give you 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and then 6 times 6. So there's many different rectangle combinations for 36 square units. But 13 has only one set of factors that multiply together to give you 13, just 1 times 13. So only 2 rectangles can be drawn. I showed you one rectangle. Can you think of what the other one would be that you could draw? Let me find my tools here. I'm not going to actually draw one. Well, maybe I will. So that one would be going this way, right? And it would be a rectangle that has a width of 13 and a length of 1. And I need 13 of these, wouldn't I? I don't know. I'm trying to make them equal in size. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, pooey. 11, 12, and 13. So anyways, that would be a rectangle that's going the other direction with 13 as a width and 1 as a length. So only 2 rectangles can be drawn with a prime number. Okay, continuing on. Alice wants to find all the prime factors of the number you get when you multiply 17 times 11 times 13 times 7. She thinks she has to use a calculator to first perform all the multiplications of the numbers and then find the prime factorization of the resulting number. So she thinks she has to multiply these all together with the calculator, and then she can split them up into their prime factors. Well, notice, I disagree because the factors that are being multiplied are already prime numbers. 17 is prime, 11 is prime, 13 is prime, and 7 is prime. She doesn't need to multiply them together at all. They're already in their prime factorization. Ryan wrote the prime factorization shown below. If he continues this pattern, what prime factorization will he show for the number 10,000, 100,000, 1,000,000, 1,000,000,000? Notice how 10 is equal to the prime factors of 5 times 2. Notice how 100 is equal to the factors of 5 squared times 2 squared. 2 zeros in 100, the little exponent is a 2. 1,000 is equal to 5 to the third times 2 to the third. 3 zeros in 1,000, 3 is the number for the exponent. So what would the number 10,000 be? Well, it would be 5 to the 4 times 2 to the 4. What would 100,000 be? How many zeros are there? 1, 2, 3, 4, 5 to the 5 times 2 to the 5th. What would 1,000,000 be? 5 to the 6 times 2 to the 6. What about 1,000,000,000? How do you write 1,000,000,000? Well, you got to go a few more zeros, right? So 5 to the 9 times 2 to the 9th. Count your zeros. Penguin. The figure shown is a rectangle. The green shape in the figure is a square. The blue and white shapes are rectangles, and the area of the blue rectangle is 24 square inches. Remember, length times width equals area. Write an expression for the area of the entire figure that includes an exponent. Well, we have to know a couple of things about geometry. This is a rectangle. The green is a square. Let me get my little spotlight. So a square has the same size, length of sides all around. Every side is the same length. So what is the length of this square here? Each side is how long? Where can I find that information? Well, if I look down here, the white rectangle is 6. Isn't that the same side as the green rectangle up here? So the green rectangle is going to be 6. And since the first one is 6, a square by definition has the same length of all of its sides. So then we can tell that this side is also 6. So now we can find the area of the green rectangle or green square by multiplying the length 6 times the width of 6. We can find the white rectangle by multiplying the 2 times the 6. And we already know the area of the blue rectangle because they told us it was 24 in the problem. So they want us to write an expression for this using an exponent. So 6 times 6, that's the first part. That's 6 squared. And then we have 2 times 6 right here, and then plus 24, which is coming from the problem. That's the area of the blue rectangle. So this is the area of the white rectangle. This is the area of the green rectangle. And this is the area of the blue rectangle. And we wrote an expression. Okie dokie. Now the next step is to solve our expression and find the area of the whole figure. So 6 squared times 2 times 6 plus 24. So first we're going to do please or parentheses. There are none. So we're going to skip ahead to exponents. We do have some exponents. 6 times 6 is 36. We bring everything else down. Plus 2 times 6 plus 24. Now we do multiply or divide, whatever comes first. Notice in this one, 36 plus 2 is not going to be first because it's adding. We have to do multiplying. So we're going to do 2 times 6. So that'll be 12, and we'll bring everything else down. And now we're going to do adding and subtracting whatever comes first from left to right. So we're going to do 36 plus 12 first. It's going to give us 48, and then we're going to bring down our plus 24, and then our last step is to do 48 plus 24. So 72 square feet is the area of that figure. I have a question for you. What is the length and width of the blue rectangle, this part right here? What is the length and width? We know the area, but what's the length? What's the width? I bet you could figure it out from the picture, couldn't you? Well, we know that this whole height here is how much? 6 plus 2 more. So it's 8, right? So that means that this side, the opposite side of a rectangle, is also the same height. So that has to be 8, right? That's going to be the 6 plus the 2. And what do we know from the problem? That the blue rectangle is 24 square inches. So something has to be multiplied by 8 to give us 24. Well, 8 times what? 8 times 3, right? So that little piece there of the blue rectangle is 3. So that's 8, and that's 3. Do you know what the length of this whole side is right here? What's the length of that side? It would be what? 6 plus 3, or 9, right? Because that's the whole length over here, the whole same length over there. Rob and Lila try to simplify 18 times 4 squared plus 9 minus 3 squared. Rob simplifies the expression and gets 360. Lila simplifies it and gets 324. Which student is correct, and what error did the other student make? Well, let's do them. Okay, let's do Lila first. So please end my day at school. Do parentheses first. 9 minus 3 is 6. And don't forget the little exponent comes along with it. Bring everything else down. Now I'm going to do the exponents. 4 squared is 4 times 4, which is 16. And then 6 squared is 6 times 6, which is 36. And then I'm going to bring the 18 down. Now I do multiplying or dividing. I have 18 times 16. When I multiply that together, I get 288. And then I'm going to bring down the plus 36. And now I do the last step, adding 288 plus 36. 324. That's what Lila got. Now let's see about Rob. What did he do? Okay, he did what was in parentheses first. What did he do? Well, he squared 9 and he squared 3. And then he brought down the rest. And then he did what's in the parentheses, 18 minus 9, which is, or 81 minus 9, which is 72. And then he brought everything, oh, he did the 4 squared, that's 16. And he brought down the 18 times, okay? Now he did a multiplying of 18 times 16, and he got 288. And then he brings down his 72. His answer was 360. Who made a mistake? Did you say Rob? And you are correct. There's his mistake. Rob squared each of the numbers in the parentheses. He squared the 9 first, and he squared the 3 first. And then he subtracted, right? You can't do that. You have to do what's in the parentheses first. He should have subtracted 9 minus 3 and gotten 6 over here and squared it. So there's his error. Okay, it's your turn to try some problems, and I'll see you back in a moment. Okay, welcome back. Your homework is on Google Classroom, and we will see you next time. Bye.